Hello, this is Miss Zaleski, and I'm going to be giving you a lesson today about direct variation. Our objective for the day today is that we are going to write and graph direct variation equations. So first of all, we need to talk about what a direct variation is. It is a relationship that can be represented by a function in the form y equals kx. So let's write this out here. We have, I love my colors today, I have a nice pretty blue. Direct variation. Now I know that some of you are familiar with a linear equation in the form y equals mx plus b. This is really similar. This is just y equals kx, k instead of m, and there is no b. So just in the form y equals kx. So our k here is our coefficient of variation. Or constant of variation here, excuse me. Let me go back. We gotta erase constant of variation. Go back. See what you get for writing this thing at about 6:30 in the morning. This is your K. And let me show you a little something here off on the side. If I take this equation, y equals kx, and I try and get k all by itself, like we did way back in chapter 2, I would just divide both sides by x, right? Now the x's cancel, and I have y over x equals k. Well, this is great because this can help us figure out what k is when we have x and y. So let's go over here and we're going to fill this in. Our k, constant of variation, equals y over x. Nice pretty pink today. So what we're going to do in this section is we are going to use this. So in our first set of problems that we have for our homework today, we need to determine if an equation is a direct variation equation or not. So keep in mind it is if it looks like this. That is a direct variation equation. So what I want to do is I'm going to use my algebra skills from chapter 2, and I'm going to write each of these in the format y equals kx. So I want y by itself here in example A, so I'm simply going to divide both sides by 7. And would you agree I can cancel the 7s, and I have y equals 2/7 x. So notice this is in the form y equals kx, and let's identify right now that k is 2/7, and let's find another color. This is a direct variation. So if we go over here to example B, I'm going to try and put this equation in the form y equals kx. So I need the y by itself. So the first thing I'm going to do is I'm going to move my 4x by subtracting it to the other side. So I've got 3y equals negative 4x plus 8. And again, I need my y by itself, so divide everything by 3. Now, when I get done with this, here's what I've got. Y equals negative 4/3 x plus 8/3. And this is not in the form y equals kx because I have this 8/3 right here. So this is not a direct variation. All right, go over here to example C. Let's see what we can do with this. So first of all, I need the y on the left by itself, so subtract 4x on both sides. Bring down my 5y equals negative 4x. Need the y by itself, so divide by 5 on both sides. and I have y equals negative 4/5 x. Now notice this is in the form y equals kx, and we can identify our k. Our k here equals negative 4/5, and this is a direct variation. The next thing we're going to do is write a direct variation equation. And I know this looks like a story problem, but really it's not that bad. So suppose y varies directly with x and y equals 35 when x equals 5. What direct variation equation relates x and y? And what is the value of y when x is 9? So the first thing that we're going to start out with is our direct variation equation. So we're going to write it y equals kx. Now if we go up here, we know that y is 35 when x is 5. So we're going to actually plug those in here. So y is 35. We don't know what k is, but x is 5. And in order to solve for k, we just divide both sides by 5. And we're going to find out here that our k is then 7. So we can write our direct variation equation. So our direct variation equation, will go right up here to the top, is y equals 7x. We'll put a big circle around that because that's our equation. The next part says, what is the value of y when x is 9? So what we're going to do is put 9 in for x. Let's go to a new color here. So I'm going to take this x is 9 and I'm going to put it right here in place of x. So I'm going to have y equals 7 times 9, which gives me y equals 63. So let's go ahead and do another example just like that. So suppose y varies directly with x and y equals 10 when x equals negative 2. All right, so here's what we're going to start with. Our direct variation equation, y equals kx. Now we're going to figure out our k. We have y equals 10 when x equals negative 2. So we're going to plug those in. So y is 10. X is negative 2. Now we can solve for k. So we're going to divide both sides by negative 2. And we find out that our k is negative 5. So go up here again to the top, and let's write our direct variation equation, which is y equals negative 5x. And we'll put a big circle around that because that's our equation. So next thing we're going to do is answer the second part, which is what is the value of y when x equals negative 15? So we're going to take this negative 15 and we're going to put it in place of x. So I have y equals negative 5 times negative 15. Oops, I didn't bring a calculator into my office here. So I'm going to have y equals 75. In our next problem, we're going to be graphing a direct variation, and we're going to use a method that you are familiar with, and that is creating a table of values. So I have the weight on Mars, y, varies directly with the weight on Earth, x. The weight of a science instrument on Mars is 50 pounds, while its weight on Earth is 130 pounds. So what is an equation that relates weight in pounds on Earth, which is x, and weight on Mars, which is y? So hang on here. First thing we're going to do is it's 50 pounds on Mars. So I'm going to circle that. And the Mars weight is y. All right, and the weight on Earth is 130 pounds, and the weight on Earth is x. That's going to help me write my direct variation equation. So I'm going to start with y equals kx. And my y value here is 50. And my x value here is 130. And I'm going to divide both sides by 130. Okay, now I've always told you if you're doing a story problem, it is okay if you want to use a decimal. So I brought a calculator in, and I've got 50 divided by 130 gives me 0.38. So I'm going to have k equals 0.38. And what that means is our equation is y equals 0.38x. Next thing I want to do is create a table of values. Okay, so I have my table of values, and there's one pair that I can put in there already, and that is that my x value was 130 and my y value was 50. Now, really, if I have one more pair, I have enough to draw my line, which is a direct variation is a line. But remember, it's a line that goes through the origin, which is at 0, 0. And this makes sense because if you put 0 in for x in this equation, x times 0.38 will give you 0. So now let's go ahead and draw our graph. Okay, so let's go ahead and graph our points now. Notice here that you can make your x and y values on your graph whatever you want as long as all of the increments are the same, which I have all the increments being the same. So I'm going to graph my point 0, 0, and I'm going to graph my point 130, which is roughly here, and 50, which is roughly there. And if I wanted to do another point, all I have to do is pick something else for x, which I could pick if I want to, pick 300. 300 times 0.38 gives me 114, and I could graph that one as well. And that'd be up there somewhere. And this gives me enough to draw a nice, straight, direct variation graph. Now, the last question we have is, what is the slope of the graph y equals 0.38x in part A? And the answer to that is slope equals 0.38. Okay, so now you're starting to see something that is true. Slope equals the constant of variation. A quick note about what your graph should look like. Not all constants are, all direct variation graphs are going to look the same. Here is the one thing that is true, and I gotta get my little highlighter out here, nice pink highlighter. The line is always gonna pass through 0, 0 if it is a direct variation in the form y equals kx. The slope of the line is k, so you can see if k is positive, your slope is positive, it's going to go up. The line will go up as you go from left to right. If the slope is negative, the line is going to go down as you go from left to right. This is our last slide today. What we're going to be doing today is from a table of values, we're going to figure out if y varies directly with x. And if it does, then we can write an equation for the direct variation. Now, I know that in the past, when we've looked at these tables, we've looked at what is the increase between the x values and the increase between the y values. We're going to do something a little bit different here. And that is, remember that we figured out earlier that k, whoops, I have my highlighter on, not my pen, k equals